Alright, in this video I'm going to teach you the chain rule. The chain rule is arguably one of the most important differentiation rules that we will look at. The first point that I want to make about it is that it applies to composite functions. So what I mean by this is that the chain rule is used whenever you have something in the form of a function inside of another function. For example, y equals sine of x squared is a composite function. We have an inside function and an outside function. You can think of it that way. X squared is a function that, in terms of our g of f of x notation, would be the f of x, and then the g of x function is sine of x. Another example is y equals x plus 2 to the power of 3. This is a composite function where the inside function, f of x, is equal to x plus 2. That's the innermost part of our function. And then the outside function would simply be x cubed. So if you can see that, we can show that g of f of x would be our f of x function placed inside of the g of x function, giving us our x plus 2 to the power of 3. So composite functions, everything that you've ever done with the composition of functions when you find f of g of x or g of f of x or f of g of 2, all of that stuff is now applying to, or the chain rule will now apply to that world of composite functions. So you can imagine that it becomes a really handy tool because many functions that you see are expressed as composite functions. You don't look at this guy and think of that as a composite function, but that's what it is. It's a function inside of another function. So I'm going to express the chain rule to you symbolically first, using this notation, and then I will put some words to it to help understand exactly what it is that we're doing. So here's what the chain rule says. It says that if h of x is g of f of x, then h prime, the derivative, is going to equal g prime of f of x multiplied by f prime of x. This is the chain rule. And as you go through and do the chain rule, as you apply the chain rule to various problems, these are the words that I want you to be thinking. The derivative of the outside. And so as we do this, we're going to be talking about the outside function and the inside function. So just to be completely clear, this is inside, and then g of x is outside. So that's what I mean as I say inside and outside. So to find the chain rule, or to use your chain rule, you're going to take the derivative of the outside, which is your g prime of x, evaluate it at the inside. So that thus far brings us here. We have the derivative of the outside, evaluated at the inside, and then the rest of this is times the derivative of what is inside. Times the derivative of what's inside. The derivative of the outside evaluated at the inside times the derivative of what's inside. I want to make sure that you can see what each piece of that means and understand that that is the process that you will go through to take the chain rule. And again, the chain rule will apply any time that you've got a function inside of another function. So let's go ahead and look at some examples. So we have y equaling x plus 4 to the power of 5. First of all, let's just take note of the fact that the chain rule applies because I have a function x plus 4 inside of a function being raised to the power of 5. So using our idea of f of g of x, or g of f of x, however you want to think of it. I guess last time we used g of f of x, so let's do that. We're going to go g of f of x. F of x, in this case, the inside function is x plus 4. G of x, the outside function, is simply a function raised to the power of 5. So if I want to find g prime if I want to find y prime, I'm going to find g prime of f of x multiplied by f prime of x. So this is kind of like my outline. This is my process that I'm going to go through. So here we go. We're going to take the derivative of the outside. So we've got a power rule. We're going to bring the 5 out front. And I'm going to raise my new power to the power of 4. And this is the derivative of the outside. And it's got to be evaluated at the inside. And now I'm going to multiply this by the derivative of what's inside. So now this is my f prime of x part. I look at what's inside and I say, what is the derivative of x plus 4? And the answer is simply 1. So y prime is equal to 5 times x plus 4 to the power of 4. Let's take a look at another one here. Y is going to equal 2 times 7x minus 3 to the power of 4. Again, the chain rule applies because I have an inside function and an outside function. I'm just going to go ahead and talk you through this one and see if you can make sense of this. The derivative of the outside, I'm going to use my power rule. 4 times 2 is going to be 8. And I'll lower my exponent by 1 to get a new power of 3. This is evaluated at the inside. So far I've taken the derivative of the outside, evaluated at the inside, times the derivative of what's inside. So now I take the derivative of 7x minus 3, which is 7, and I am done, except for the fact that I can simplify this a little bit more. 8 times 7 is 56, and we are done. In this example, y is going to equal the square root of 4x squared plus 2. Again, chain rule applies. I have an inside function and an outside function. The outside function is simply the square root of x. So let us see what we can do with this. Y prime, the derivative of the outside, if you remember that the square root is the power of 1/2, I'm going to bring the 1/2 out front, and this is evaluated at the inside. I will lower my exponent by 1, and then I need to multiply this by the derivative of what's inside, which will give me 8x. So my best final answer here would be like this. Let's change that. We're going to have 8x in the numerator. In the denominator, I'm going to have 2 multiplied by the square root of 4x squared plus 2. And the last thing that I can do here is simplify the 8 and the 2 to give me 4x divided by the square root of 4x squared plus 2.